Morning, everybody. Today we are going to learn about the Newton's divided difference table method for interpolation. Here, firstly, we will go to the introduction part of this. It's the Poynting polynomial interpolation technique for estimation of unknown values between known data points using divided difference tables. Here, the interpolation is the process of estimation unknown values between known data points. Divided difference interpolation constructs interpolated polynomials using divided differences, a systematic approach building approximation functions. This method is fundamental in system analysis for curve fitting and data approximation and solving real-world engineering problems. Here, the first divided difference formula is fxi xi plus 1 equals to fxi plus 1 minus fxi divided by fxi plus 1 minus fxi. And the generalized Newton's interpolation polynomial is px equals to f of x0 plus x minus x0 f x0 x1 plus x minus x0 x minus x1 f x0 x1 x2 and goes on. The advantages of this method is it handles uneven intervals easily, efficient incremental calculations, and allowing added new data points without full recalculation. There are some disadvantages of this method also. It's tedious for large data sets when done manually, prone to calculation errors by hand, increasing complexity, high order differences. Now we will solve a question understand the method easily. Here the given data points are x 5, 7, 11, 13, and etc. And the function value of these data points are given also. And now we have to find the value of f of 9 using the divided difference method at the interpolated value at x equals to 9. Here we will make a table of x and fx. Now we will find the first order differences of given points as shown in the video, and now second order differences required by the formula for finding a function of 9. Now the complete divided difference table here shows all calculated orders starting with fx values. We compute successive differences: first order, second order, third order, and fourth order. The diagonal values 150, 120, 24, 2, and 0.25 form the coefficient of Newton's interpolating polynomial. Now, the final interpolation formula and calculation. Here to find the P9, we will put the values in the formula which is shown in the video like fx0, x minus x0, f, x1, comma x2, and x minus x0, x minus x1, f, x0, x1, x2, x0, x minus x0, x minus x1, and x minus x2, f of x1, x2, x3, and so on. Now the stepwise calculation is shown here, and now the P9 is equals to 1450, 484 plus, and now 810. The final answer is 800. Function of 9 is 810. Now we will go through the Python program. Firstly, we define the divided difference function, where we will do n equals to length of y given, and coefficient equals to np dot 0 n comma n. Now coefficient we will equate it by less than 0 equals to y for j in range of 1 comma n, for j in range of n minus j. For we start two for loops, and now to find the divided differences of the given functions, we will do coefficient of I equals to coefficient I plus 1 j minus 1, and minus coefficient of I j minus 1 divided by x I plus j minus x, and return the coefficient. And now we will define another function, that is Newton's polynomial and pass the arguments coefficient x data and x. Now n equals to length of x data minus 1 and p equals to coefficient of n. And now we start a for loop for k in range of 1 comma n plus 1. And we will apply the Newton's divided difference formula and return the final value. And here in our main program, we will define a list x to list x and y, and then call the divided difference function and the Newton polynomial function. As a program output and applications, interpolated value we find at x equals to 9 is 810. And in real world application, this method is used in scientific computing and research, engineering analysis, and design. Data fitting and curve approximation, numerical prediction, and forecasting, computer graphics and animation, signal processing and filtering. So now we have understood the Newton's divided difference method, and its key takeaways are Newton's divided difference method is powerful for polynomial interpolation, efficient with unequal interval, and increment data addition. Python simplifies complex numerical calculation, essential technique, numerical method, and computational math. Now, in our next video, we will learn another method. Thank you. That's all for today. Have a nice day. Like, share, and subscribe. Thank you. Have a nice day.